Okay, so I wish to quickly speak to you about special right triangles. And what you need to know is that there are two kinds of special right triangles. Okay? Triangles. One of the special right triangles is called a 45, 45, 90 triangle, and those refer to angles. So what that means is that two angles are the same measure, 45, 45, 90, and the other angle is a 90-degree angle. So if this is 45, and this is 45, and this is a right triangle, that qualifies as a special right triangle, which means that these two sides have to be equal because those two angles are equal. So if I say that the measure of this leg here is x, and this is x, then the measure of the hypotenuse is going to be x times the square root of 2, always, regardless of what the measure of the side is. Okay. The second kind of special right triangle is what we call a 30-degree, 60-degree, 90-degree angle. So in that case, the legs are not congruent. Let's say this is a right angle. Let's say this is 60 and this is 30 degrees. This is the ratio of their sides. If the shorter leg, which is the leg across from the 30-degree angles, is x, the longer leg, which is the leg across from 60 degrees, is always going to be x times the square root of 3. And the hypotenuse, which is across from the right angle, is always going to be 2 times the short leg, or 2x. That's what you need to remember. So how do you apply that? Well, let's say, for instance, that I give you the measure. I say that this triangle here is a 45, 45, 90. I know it doesn't look like it, but let's say that it is 45, 45, 90. And this is a right triangle. Let's say, for instance, that this is 10 units, this is 10 units. If I ask you to find the measure of the hypotenuse, you would just say 10 times the square root of 2. It's that simple. Now, if I give you the measure of the hypotenuse, and let's say this is once again a 45, 45, 90, which is isosceles right triangle. If I tell you that this is 5, and I want you to find this, you take 5 and you divide by the square root of 2. But then you have to rationalize, and by that I mean you have to multiply top and bottom by the square root of 2, and your final answer would be 5 square root of 2 over 2, which should be the same measure over here. Okay? Same principle applies for 30, 60, 90. I always try to work from the shorter leg. So let's say, for instance, that we're looking at the 30, 60, 90 triangle. I'm going to do that right here. And I'm going to say, okay, let's say you're told that we have a triangle like this, and this is 60 degrees, this is 30 degrees. Let's say this is 3 units, and I ask you to find this and to find this. Well, this would be the shorter leg because it's across from the 30-degree angle. The longer leg is always going to be 3 times the square root of 3. And the hypotenuse is always going to be 2 times the short leg, 2 times 3, which gives you 6. So now you have all 3 measures. These are shortcuts for triangles with these angles. Now, what if I do this? Well, let's say this is 60, this is 30, this is 90. Suppose that I give you the measure of this side and I say it's 6. And I say, okay, what is the measure of this side? So then you have to do 6 divided by the square root of 3, because I know that the long leg is always the short leg times the square root of 3. So going backwards, you have to divide by the square root of 3. And then you have to rationalize, and you get 6 radical 3 over 3, which is the same as 2 radical 3. And once you have that, to find the hypotenuse, if you were asked to do so, you have to multiply by 2. So you get 4 square root of 3. Okay? So that's all there is about special right triangles. You're going to get some practice on IXL and other also hold, and reach out to me if you have any questions. Very good. Thank you.